Alright, this is Mr. Gillum, and today we're going to take a look at modeling division. So we've modeled some addition, we've modeled some subtraction, we've even modeled some multiplication. Today we're working on division, and so we're going to do some visuals here. Now, this is actually the top and the front page of your division packet. And the first thing we're going to do is we're going to use these nice squares here to visualize division. And so it kind of gives you a nice example at the very beginning. It says 1/3 divided by 4. So we want 1/3 into 4 pieces. So we're going to start with a whole, and we're going to divide it into 3 pieces. Now, since we're just talking about one of the 3 pieces, you can see they just shaded in 1/3 of the pieces. Okay, because I want 1/4 of that 1/3. I'm dividing it into 4 pieces. I then make 4 even parts. However, I only want one of those 4 even parts. And that's where I think that the visual gets a little bit tricky. When I'm dividing something by 4, I want to know what 1/4 of it is. So once I divide it into 4 pieces, I want 1/4 of the shaded region. It would just be 1 right there. And there are a total of 12 different parts. So I need to know how much this black shaded region represents as compared to the entire diagram. So if I count how many there are, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 total portions there. So one rectangle would represent 1/12. So 1/3 divided by 4 would be 1/12. Okay, so I'm going to do 3 examples with you here to get you started. And again, similarly to the example problem, we're going to take 1/3 and divide it by 3. So again, I'm going to divide this into 3 parts as evenly as I can. And I'm talking about 1/3 of this. I'm going to use black marker. So I'm modeling 1/3 right now. That's what I'm doing. And when I'm dividing, I want to see what 1/3 of 1/3 is. I'm dividing just this black shaded portion into 3 parts. And so if I'm dividing it by 3, I'm going to go ahead and chop it into 3 parts. And I want one of those 3 parts. So I know that 1/3 divided by 3 is 1 shaded part out of 1, 2, 3, 4, 5, 6, 7, 8, 9 total shaded parts. And you can always check to see too, 1/3 divided by 3 is the same as 1/3 multiplied by 1/3. We know this, and again, I will get 1/9. Okay, so this is just a way to visualize. Let's take a look here, and this is going to be a little trickier for me because I'm going to first of all model 1/8. So I need 7 lines here. Not bad, Mr. Gillum, not bad. They're a little crooked, a little not quite the same, but that's all right. And 1/8 would be represented by just one of the 8 sections of the whole. So I'm going to shade that in. I'm dividing that 1/8 of a section into 8 parts. I want to know what divided by 8 equal pieces would be. So I'm going to take my green marker, and again, I'm going to just chop this into 8 parts, 7 up and down. 1, 2, 3, 4, 5, 6, 7. Man, that was a good one. Okay, and so I want 1/8 of 1/8. Or I'm dividing 1/8 into 8 equal pieces. So I just want 1/8 of 1/8. So that much of the rectangle is 1/8 of 1/8. So I have one of the rectangles, and there are a total of 64 rectangles altogether. So 1/64 would be my answer. Okay, and like I said, you can always double check again to see. And then finally I have 1/7 divided by 2, so I'm going to go ahead and do 6 lines here. 1, 2, 3, 4, 5, and 6. And 1/7 will be represented by shading in one of the 7 parts of the whole. Now if I'm dividing it by 2, I want exactly half of it. So to represent that, I'm going to chop this whole into 2 pieces vertically. Right there. I'm dividing it by 2, I want 1/2 of it. So right there. So I need to know how much this rectangle represents as compared to a whole. Well, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 total pieces, and one of them is double shaded there. So 1, 14th is what half of 1/7 is, or if I divide 1/7 by 2, it is 1/14. Okay, so that's my first type of modeling. Then I want to model on a number line, and this is the tricky one here. Most of your problems will work out nice and evenly, but some of them don't. And so what I'm going to do is I'm going to think like this. I want to divide 4 into 8/9, meaning I want to see how many 8/9 will fit into 4. So I need to start marking off 8/9 until I make it all the way to 4. So my first 8/9 would be from here to here. That's 1/8 8/9 right there. So there's 1 time the 8/9 fits into 4. Then 1, 2, 3, 4, 5, 6, 7, 8. There's my second 8/9 that fits into 4. And then 1, 2, 3, 4, 5, 6, 7, 8. This guy's my third 8/9 to fit into 4. And I have another 8/9 that will fit. 1, 2, 3, 4, 5, 6, 7, 8. That's an 8/9, and it fits into 4. So far 8/9 has fit into 4 times, but what I notice is I'm not going to fit another time. And now here's the tricky part. There are 4 spaces left, but I'm not actually wanting the distance. I don't want to put 4/9, so I'm not going to put 4 and 4/9. Okay, that would be incorrect. I usually go 8 spaces because I'm talking about 8/9. So really, the next one, I'm going 4 spaces out of my usual 8 spaces. So my fraction would actually be 4 and 4/8, or 4 and 1/2 would be the best answer. Okay, so an 8/9, the first 8/9, the second 8/9, the third 8/9, the fourth 8/9, and then half of the numbers, 4 of the 8/9 will go into the next one. So 4 out of the 8 pieces will go in. So 4 and 1/2 will be my solution. Let's try it again with 5/6, and I'm going to put a nice mark here on 2 because that's where I'm going to stop. Okay, I want to see how many times 5/6 will go into 2. So 1, 2, 3, 4, 5. It fits in once. And 1, 2, 3, 4, 5. There's number 2. And obviously I'm not going to be able to fit another whole 5/6 in there, but I can fit 2 of the pieces. 2 of the 5 pieces that I was going to go. Each one I'm going 5 times. So I see 2 and 2 of the 5 I was actually going to go. All right. I know that this distance is 2/6, but we're not referring to it as a distance. We're referring to it as a portion of the 5/6. So 2 of the 5 that we usually go. All right. And then finally, some reminders, because we need to practice our division still. I notice we're still having a hard time with some of these. Reminder on division. The first fraction stays the same. Division changes to multiplication. And the second number flips over. So instead of 2 over 1, we have 1 over 2. Again, I want you to reduce, reduce, cross reduce, cross reduce. In this case, there's nothing to do, so we're going to have 1 over 12. All right. Let's take a look at the next one here. It says 6 divided by 1/4, which is really the same as 6 over 1, times 4 over 1. Reduce, reduce, cross reduce, cross reduce. Nothing's going to reduce with these 1s down here. So I know that 6 times 4 is 24, and 1 times 1 is 1. Or 24 is our best answer. We don't need to keep the 1 on the bottom there. It's like a placeholder. And finally, 1/2 divided by 2 would be like 1/2 times, oop, not 2 over 1, Mr. Gillum. You have to flip that fraction. It says 2 over 1. We're going to multiply it by 1 over 2. And so again, I would reduce, reduce, cross reduce, and I would know that what's left is 1/4. Okay? So again, with the mixed numbers, and we're just doing some extra practice here because I know these are tricky. Before I do any division, now in addition and subtraction, you can get away with leaving them as mixed numbers a little bit better. But with division and multiplication, we need to make sure we change all our mixed numbers into improper fractions. So I'm going to start by changing this to 4 times 3 plus 1, 13 over 4, divided by 3. Okay, just change it from a mixed number to an improper fraction, which is really 13/4 times the reciprocal of 3, which is 1/3, And now I can reduce, reduce, cross reduce, cross reduce, and multiply. 13 over 12. Or if you like it better as 1 and 1/12, that would be fine as well. Okay? Just remember, if you reduce, reduce, cross reduce, cross reduce, you'll always have the simplest form when you're done. And now one more complicated. 5 times 4 plus 4 is 24 fifths, divided by 3 times 5 is 15, plus 1 is 16 thirds. And now I'm going to take 24 fifths, and I'm going to change division to multiplication, and I'm going to multiply by the reciprocal is what that word is called. Now, it's going to be important for me to know how to cross-reduce on these bigger problems, otherwise we're going to have some big numbers to work with. 24 and 5 don't reduce, neither do 3 and 16. However, I do know that 24 and 16, 8 goes into both of those numbers, into 24, into 24 3 times, and into 16 2 times. Now, and of course 3 and 5 don't have anything that they share as a common factor, so 3 times 3 would be 9, and 5 times 2 would be 10, 9 tenths. Okay, so those problems are on each page of the first 3 pages of your worksheet. When we're going to, I'll give you the assignment when you get to class, and you'll have these ones done. So that's it for now.